Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all of the participants. Today, we with the Aspa Center, we have a talk with Dr. Janatul Madiha with the Discovering AI Unlocking the Future. This talk will be take 3 hours from 9 a.m. to 12 p.m. And we will have a welcome speech, some introduction. At 9:30 to 10:30, we have a lecture one. 10:30 to 10:45, we have break and photo session. And we have a lecture 2, 10:50 to 12 p.m. So without further ado, I would like to introduce the speaker for today. Dr. Janatul Madiha Abu Bakar merupakan seorang pengamal perubatan sejak tahun 2016. Beliau mempunyai kelulusan ijazah sarjana muda dan Queen's University of Belfast, ijazah sarjana kesihatan awam dari Universiti Kebangsaan Malaysia dan mempunyai sijil pengajian Islam UMCSET. Daripada dia mempunyai pengalaman yang luas dalam bidang penulisan dan pelbagai genre termasuk buku, e-book dan penulisan popular, puisi dan penulisan akhbar, majalah dan lain-lain lagi. Beliau juga menjadi penyunting bagi tesis, artikel ilmiah, majalah dan buku. Minat yang mendalam dalam pendidikan dan penulisan membuatkan beliau terus berkecimpung dalam bidang ini dan samping tugas sebagai hakiki sebagai NGO yang disertai. Beliau juga telah menyertai Train of the Trainer anjuran AI Singapura pada tahun 2024 dan seterusnya ditauliahkan sebagai Certified AI for Good Instructor daripada Singapura. Oleh itu, marilah sama-sama kita membuka majlis kita dengan umum kita Al-Fatihah. Auzubillahi. Ya. Tanpa membuang masa, saya menjemput Al-Fadilah Ustazah Dr. Janatul Madiha Abu Bakar untuk berkongsi ilmu kita tentang AI, Discovering AI Unlocking the Future. Dr. Jana, the floor is yours.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamualaikum and a very good morning. Thank you to Mrs. Professor Moderator, Professor Madia, Associate Professor Dr. Aspalila alias, for the kind introduction. From this point onwards, my speech will be in English. Apologies for those who are listening, as the slides are all in English. We haven't had the translated version yet. And hopefully there will be no difficulties in understanding. It should be quite simple, and hopefully everybody can get to understand and learn the foundations of artificial intelligence in this short webinar. Right, let me just share my screen. Okay, before I begin, let's just learn a little bit about AI Singapore. Who is AI Singapore? AI Singapore was launched in 2017 where they bring together all Singapore-based research institutions and the vibrant ecosystem of artificial intelligence startups and companies developing AI products to perform use-inspired research, grow knowledge, and create tools and develop the talent to power Singapore's AI efforts. During this short webinar, we are expected to learn the fundamentals of AI in 10 different topics, and hopefully will impart knowledge about AI to more people in the community. Right. As a disclaimer, this is in support of Singapore's national AI strategy and their goal of training 15,000 people in AI by 2030. Meta and AI Singapore are partnering on this two-pronged program, and where the part one of the program is supporting AI upskilling for up to 4,000 AI student practitioners in Singapore. And part two of the program will support Singapore's leadership at the forefront of AI by scaling home-ground AI upskilling education to ASEAN countries. Yeah, the Singapore program supported 100 teachers for TAI workshops in Asia, and hopefully to reach 5,000 students by the end of this year. So let me just introduce myself. I'm Dr. Janata Madia Abu Bakar. I'm one of the trainers or instructor from Learn AI Singapore, where I actually attended a Train the Trainer program organized by AI Singapore in collaboration with Meta, which was done in 2024. And hopefully this program is actually being done at a regular basis, and they are recruiting more people to become the educator for AI for Good Educator program. The purpose is to advocate artificial intelligence use ethically and to make sure that people know what AI is and not to be afraid of using AI, artificial intelligence. Okay, so this is the certification that I have received from AI Singapore and Meta. And after that, I was quite interested in doing more of the courses. So I completed the AI for Everyone course from AI Singapore. And I've also successfully completed the AI for Industry Literacy in AI short course as well. And after that, yeah, I think that the AI is very addictive. So I tried, and I want to see what Python is, because I've heard about Python so much, but I haven't learned about it. So I did my introduction to Python course. Even though it is mentioned here, the length is 4 hours, it actually took me longer because there were breaks in between. And also it took me some time to actually understand what Python is. But don't worry, I'm not going to teach you Python today. I'm just going to let you know that once you know about something, you feel that you don't have enough idea of what it is about, and you secretly wanting to know more about that. So I'm just grabbing all the opportunity that I can while I can to do all the courses that is being given to me by the company, by AI Singapore. Okay, so for those who will be joining and watching the video for today, you will the first 100 participants will receive this certificate of completion from AI Singapore, and those who didn't make it, who don't make it to the first 100, will be awarded. Everybody will be awarded a certificate of attendance by Dr. Aspa Center Group Sdn Bhd. Okay, so don't worry about that. Okay, so before we begin, let us play a game, a game of AI or not. So in this session, you will take out your phones and scan this QR code, or you can go to this website. I can go to this website. Let me just see if I can grab the, right. So you can scan this QR code, and let me just open the Mentimeter. This is again by using Mentimeter. You can use Mentimeter for your education purposes, or you can use for quizzes online. Of course, it is of limited let me just open this first here. Of course, this is a limited if it's free, so limited to 50 participants for this for 1 month. So if you're doing in small groups or small, only a couple of students and small number of students, then you can use free version of Mentimeter. If not, you can try and find other sites. I'll just share. Just going to share my Mentimeter. Right. So other sites that provide free quizzes and things like that. Okay. So the first question, facial recognition on smartphones is an AI application. Right. Let me just see if you can. Okay. Right. We don't have any joiner for this session. Let me just go back to the QR code. Okay, so this is the QR code. Okay. So if we, right. So we will go to this next slide. You can try this again in the next a couple of days. So we'll just proceed with our talk for today. So the next slide will be the beginning of the talk today. So let me just share with you. So the topics we are going to do today is actually, there are 10 topics involving AI applications, algorithms and data, machine learning, deep learning, computer vision, how LLM works, applications of generative AI, impact of generative AI, responsible AI use, and AI jobs and me. Okay, so we will try and do the first half within the first half of the first 5 within the first half of the session, and we'll do the second 5 in the second half of the session. Right. So AI applications. What are AI? What does AI mean? Okay, so the term artificial intelligence is actually has been around for quite some time, but the recently revised definition is an AI system is a machine-based system that, for explicit and implicit objectives, infers from the input it receives how to generate outputs such as predictions, contents, recommendations, or decisions that can influence physical or virtual environments. Different AI systems vary in their levels of autonomy and adaptiveness after deployment. So what does it mean? Basically, artificial intelligence are programs that can sense, reason, act, and adapt according to the input that we give. And all of us are actually using some sort of artificial intelligence in our daily lives. For example, when I talk to my Google in my car, um, you know, I just mentioned the name of the place. Of course, we have to mention it using the right language and like slang, if right slang, if not, they will not understand it. Yeah. So, and also people talk to Google to wake them up for in the morning. So Google wake me up at 6 a.m. tomorrow. So the phone will sound the alarm at 6 a.m. in the morning. So AI can actually hear. While waiting for my to pick up my daughter from school, then I will ask Google, how is the weather today? Yeah, in the car, so the Google will answer the weather is sunny with possible bouts of rains a little bit late in the afternoon. So AI can actually speak. Yeah. When I go to the office, the robot vacuum is actually doing its sweep and it is avoiding the obstacles such as the walls, the bins and everything. So AI can actually move. And during lunch, I'll snap the picture of my food. And since I love the bokeh effect, I will turn on the food mode and the camera will detect and focus on the food, but the surrounding areas are slightly blurred. So AI can see, right? When I get home, I turn on my Netflix and it will suggest to me the movies that I might want to watch according to the movies that I have watched previously. Okay, so AI has been learning my preferences, which means AI can learn. And as you can see, from the moment that you wake up until you go to bed, you are actually interacting with AI. And a lot of us are actually wearing or putting on some sort of smartwatch and using smartphones. These are all AI applications which have been incorporated into our uh, our gadgets. Yeah. So different AI models are actually developed for different purposes. For example, facial recognition in the offices, in the security systems, in our phones. So when we are giving the AI some input, and in terms of face images, so the model that has been created will learn about the input that we have given and give the output, okay, which are the predictors or a certain type of classifications, okay. For example, when we use the Face ID on smartphone, you show the image, your image, so the AI model will recognize the facial ID and identify you as the owner of the phone. If you scan somebody else's image, the facial ID in your smartphone algorithm will not recognize it. Thus, they don't open the phone for the other person. Okay. Same goes to the shows that has been watched. So, for example, if you have systems like Netflix and the likes, you will be recommended to the shows that you might like based on the shows that you have watched before. Okay. If you haven't watched anything in that using that system, then they will just give based on the trends, based on certain criteria. For example, your age, your gender, your other preferences like the shopping malls you go to, things that you purchase over the internet and things like that. Okay, this is provided that you connect all these items with your say Google or your Google account or your Apple ID account and things like that. Okay, so there has to be a system for you to use these models before you actually begin, right? Before you actually begin, and the model will recognize the input and process it to produce an output. And why are these becoming more rampant nowadays? Okay, you see everywhere, the people are using AI, people are using smartphones, people are using gadgets, devices, and things like that. So companies are now generating more data by using smart appliances such as smart fridges, smartphones, smart watches, smart cars, all the smart things, yeah, smart homes. So based on this, each and every device that is being used have their own collection of data. So based on this data, they collect this data and use this data to generate more algorithms and generate more functions for using artificial intelligence. Okay. Secondly is the cost. The cost of computing is now less than before. Last time, the cost of running of having a computer, yeah, was very costly. Okay, and because the computer is huge, so you can only put like one or two in one area, and you have to buy the ones with huge memory, and then they create these USB drives, and then they create the external hard drives, and these external drives are actually getting smaller in size, but getting bigger in storage. And also there are now cloud computing, which is nowadays they are trying to get more people to subscribe to their services. So they're reducing the prices and also making it more affordable to a lot more people. Okay. The third one is the algorithm. There are more algorithms being produced every week, every month, some maybe every day. We don't know that. Okay, the scientists are working to create more and more algorithms to fit the needs of the people. And there are also easy access and open source software available on the internet. So it makes it more available. Yeah? So there are more people that can access these items, artificial intelligence, wherever they are. So what are the AI applications that we have in everyday technology? As I mentioned just now, visual ID in your offices, in the security areas, such as, nowadays they are providing humanless marts or shops. So you use the facial ID to go into the shop so that they don't need to have any security guard. They don't use any human cashiers. So everything is done using AI technology. Okay. We also have AI powered wearables such as our watches. Yeah. Which will collect data on whatever you need. Yeah. So we have data on our heart rate, we have data on our how many steps that we do every day, and things like that. And also nowadays companies are using chatbots, and chatbots are AI powered. Even WhatsApp technology also is now using chatbots or WhatsApp bots or whatever bots they are using to reduce the human needs in these areas. But of course, they will need some sort of human input later if the questions are not answerable by these chatbots. And these chatbots are actually working, yeah, by the input that has been given to them by the developer. Okay, so those who develop the AI chatbots will key in or give input as to what questions are frequently asked and the answers that they are going to give. Okay, so now we go to the next topic, which is the algorithms and data. This is a little bit of mathematical equations in here. So if you're interested in maths, Probably this can be interesting to you as well. So, what is AI? AI is basically the combination of data and algorithms, because data is being put into the algorithms, and data is being used to create the algorithm, and later data will be used to input into the algorithm and to produce the output. Okay, so data is the information needed to solve the problems that we have, from text, images, audio files, and even videos nowadays can be used as data. Algorithms are a series of mathematical equations and operations that a computer executes. Machine learning algorithms are used to understand your data. Then the model that they use is the representation of the physical world. So for example, if you have a problem in the real world, you cannot possibly bring the whole problem into your lab. So you will create a mathematical equation or a smaller version of that real life experience and try and recreate it in your lab or in your experimental setting, and then you will extrapolate the results as to put into the real world phenomenon. Okay, so you're welcome to play this game, right? At your own pace. So you can design a birthday card using auto draw in 1 minute. Okay, let me just show you what it is. Yeah, so we go to autodraw.com. I just want to show you what. Let me just clear this up. Just change the screen. Okay, so this is autodraw.com. Okay, what we want to try is actually to create a birthday card. So I would just want to draw a birthday cake. Okay, so let me just try and draw a birthday cake. Sorry, you should click this auto draw. Yeah? So let me just start over. Click auto draw, and then let's draw a birthday cake. Okay, can you see up here? They already have the suggestions of what you are going to try, what you might want to draw. Okay, so because I want to draw a birthday cake, I just want to make a simple birthday card. Maybe I'll use this one. Okay, and I want to change the color, so I just change the color to wait, hold on. I cannot change the color now. So I just want to add on the color, and there's a different color for the bottom and different color for the candles. Okay. And I want to add a little bit more, added some balloons here. So as I draw a circle and then the string, so they have suggestions of possibly lollipop and hot air balloon and things like that. So, and there are a lot of kids. There's a balloon here as well. So I'm just going to get this balloon here, or maybe I should have changed the color first before I start drawing. But anyway, so I'm just going to draw another balloon. So I'm just going to change the color. So another balloon here. So yep, oops. I would undo that. Okay. Right. So, and you can write text on it. So, what I want to let you know is this simple drawing can be used is using algorithms to find out what we might want to draw, based on the input that has been given by other people as well and the developer of this program. So you can draw this, you can use this to play with your kids, to play with your friends, okay? So you can do this as an activity for your bonding together with your family members. And you might want to get to see whose drawing can be, turned into a birthday card or whatever in a short period of time. Okay, so what are the types of data that we have? So in machine learning or in artificial intelligence or in life, we have different types of data where we have the structured data, which are whole numbers of data or in terms of text and numbers that can be tabuted, that can be arranged in a table and can be categorized in a sort of a table. And on the other hand, we have the unstructured data. Okay, the unstructured data is the exact opposite of structured data, where there are no set rules like the images, audio, video. So these are unstructured data. And in between, there are semi-structured data, which means that there are unstructured data that can be categorized or grouped together, and they can also be tagged to allow organization of these unstructured data to become semi-structured data. So we have these three types of data that are being used in artificial intelligence. So algorithms are mathematical representations of the relationship of relationships between the variables. Okay, so let's say that you in a research level, real world problems are represented using mathematical equations, and these solutions are derived by solving these algorithms, whether they are simple mathematical equations or a combination of simple mathematical equations combined together to create a more complex one. These will be solved in the lab or in experimental basis, and then be extrapolated, and the result being used or applied in the outside world, right? For example, in a lab experiment, data are collected and plotted in the X and Y axis. Let me just see. Okay, the X and Y axis. So this is an example of the simplest representation of a mathematical equation. So if you have done maths before, you might have seen this linear regression, right? Where the data is plotted along the X and Y axis, and the best straight line, and the straight line of best fit is drawn, in between the data, finding the best line of fit. Okay, and by using this graph, we can now predict or calculate. Okay, so by using the graph, we can draw a line from this value here, okay, to here. If you know the X value, to find the Y value, or vice versa. So we have the Y value. Okay, we want to estimate the X value. So we go from here to here, and then we go straight down here, right? So when you have the mathematical equation, then you can insert the numbers, the values straight to the mathematical equation. Okay, so if you want to find any value of y, if you have because m and c is constant, m is the what you call this one, the kecerunan, or the acceleration, or the gradient of the line, and then you can put in your value here, and then you can get the y level. Okay, or if you have the value of y, you can rearrange the equation to get the x. Okay, right. So by using these equations and algorithms, we can produce other outputs and produce results according to the purpose of the algorithm. So, but in life, you don't have this linear regression, just simple like that. It might be multiple linear or polynomial and many other types of equations that can be produced based on the purpose of the experiment. So after they create the mathematical equations based on the problems that they want to solve or the findings that they want to find, then they train the model. Okay, why do they need to train the model? Because they need to make sure that the model of the mathematical equation will give them the right output or the best output for the input that they give. So they will give a sample of some values as the input, as the data, and see if the algorithm works to produce the output that they need. Okay, but in real life, data is sometimes not as accurate as we would like it to be. Yeah, most of the data that's available in real life are almost always messy. So garbage in equals garbage out. So we put bad data in, we can get bad results. Okay, and the common problems that are faced by the scientists or researchers are incorrect labeling, missing values, and things like that. Okay, so a good representative data set is equivalent to a good understanding of the population. Yeah, if they get the good understanding of the population, means that the model can predict the outcome more accurately. All right, so what are the differences between the good data and bad data? Okay, so good data consists of accurate, complete, consistent, relevant, and representative data. And bad data are these inaccurate, biased, incomplete, outdated, inconsistent, duplicates, irrelevant, and they contain outliers. So how do we go about with these kind of data? So we do need to do a little bit of cleaning of the bad data before we can actually get the good data. And sometimes if you want the data to be representative, you need to go to the particular population to get the right sampling. For example, if you want to do, if you want to find something about the some ethnic minority in Sarawak, so we have to go to that area to get the sampling from that population. Then only we can learn more about that population, and then the data will become representative, and the model will become more accurate as to the right representative of the population. Okay, so if you want to know about the some ethnic minority in Sarawak, but we are sampling from the people in Semenanjung, then it won't be the right representation of the population. So that is why we need to have good data to make sure that whatever we collect and we put into the model will produce the right and the more accurate results. Okay, so basically artificial intelligence, they're not magic, they are just maths. So we can now realize that everything that we do in life has got some sort of mathematical equations and mathematical inputs in it, right? The data that we have, the numbers that we use, that we produce, and the numbers that come out from the algorithms and things like that are just mathematical equations that are being put together smartly in a certain way to make sure that you get the right results. Okay. So we've come to the third topic of the day, the machine learning. Okay, so the evolution of artificial intelligence is actually have been quite some time already. So the term artificial intelligence itself is not very new. Okay, this term is actually have been around since 1956. Okay, if you remember the movie AI, it actually is representation of how how people have been worried about artificial intelligence since that year. I can't remember exactly what year that movie was in, but it was during my childhood, so it must be about a few decades old. Okay, right. So there are many branches of artificial intelligence or school of thoughts at that time. There in 1940s, the rules they use the rules-based systems or expert system, where researchers believe that the way human mind works can be described by rules. Yeah. For example, a tiger has sharp teeth, a tiger eats meat. Hence, a dog that has sharp teeth eats meat. Okay. That is based by rules or observations that people see. Okay, then some prefer a more mathematical approach using search-based method to solve problems like the shortest delivery route. So they will use the straight line or the, okay, of course, we cannot go through houses, you cannot go through walls and things like that. So they use mathematical equations to find the best or the shortest delivery route. And then we have the connectionist approach, yeah, where the neural network in the brain is similar to the artificial neurons. Okay. So now we know that artificial intelligence are programs that can sense, reason, act, and adapt. And machine learning is actually algorithms that can learn patterns in data over time. Okay, so with the development of personal computers and digitalization networks around the 1980s, more and more data are actually being collected and readily accessible. Okay, of course, it's not as accessible as it is now, but it is more than when they had it in the 1950s. Okay, this as more data are actually collected, this gives rise to the more statistical learning, machine learning algorithm, such as the regression trees, and we'll talk about that a little bit later. Okay, so uh, machine learning is the algorithms that learn patterns of data over time. Yeah, for example, let's see these shapes over here. Yeah. It is, so now it's triangle, circle, rectangle, triangle, circle, rectangle, triangle, circle, circle, and what do you think is going to be next? Yeah, surprise, surprise, it's a rectangle. Okay, so that is how machine learning learns the algorithm. So it has to be a lot of data over a certain period of time for them to learn before they can actually become good at it, right? So in some cases, there might be some issues, maybe some mistakes, simply because there are not enough data or they're not there long enough to learn the right pattern. Okay, and so of course, sometimes we have outliers, we have some inaccurate data, as what we learned about bad data just now. So that can cause some problems in the machine learning algorithms as well. Okay, and then let's just ignore this next two happenings, right? Okay, so what does machine learning consist of? Okay, so machine learning consists of a lot of forms of learning, but the two most common forms are supervised and unsupervised learning. Okay, so taking for example the apps Carousel, if you have ever used one before. Last time when using this app, a seller will have to upload an image of the item they are selling, and they have to categorize in which category the item belongs to. Okay, for example, they want to sell okay, they want to sell a bottle of water. Okay, the bottle of water, then they will have to upload the picture, the image of the bottle, the water bottle into the app, and then they have to categorize whether it is a beverage, whether it is a drink, whether it is food, whether it is a perfume or whatever. So they have to categorize it themselves, right? And then recently, yeah, Carousel automatically recommend the category as you upload a picture. Yeah, for example, you upload a picture of a pen. So they will automatically categorize it as stationery and probably a few other recommendations of categorization that you might want to use, for example, gifts or souvenirs and things like that. Okay, so how are they able to do this? Okay, they do this by, you remember when the seller needs to put in the category. So after some time, the developer, the scientists around the system will set the algorithm to recognize, yeah, to recognize the categories, recognize the items, and learn which items belong to which category, and if it fits to be in that category. That's why you have the option to remove a certain category, because sometimes it looks as if it belongs to that category, but it doesn't. So we still have the opportunity to change the classification if it doesn't fit our purpose, right? So again, we are not the only one putting. Okay, one seller is not the only one putting it in the putting in this data. Okay, there are thousands, other sellers that key in the similar type of data. Okay, so Carousel uses this input to train their AI model and to learn that this item of this feature belongs to a certain category or categories. Okay, so in supervised learning, um, you have a labeled data set and it predicts a target variable. Okay, so in supervised learning, we have two um, classification or two branches. So the first part of supervised learning is a regression, which involves the numerical values. And the second part of supervised learning is a classification. It is non-numerical. So it involves classifying the items according to certain set of classes. Okay, so let's go to regression first. So regression is a form of supervised machine learning using numerical values. Yeah. For example, weather forecast. Okay. Daily number of COVID cases. The property prices according to the values of surrounding areas and other factors that involved with it, like flood, crime rates, distance from facilities and things like that. Okay, so this regression basically uses numerical values. Okay, um, so what is the important thing about regression is the label. What Okay, so our data need label. Our data need label. Is for our data need label. So label is very important. And so we are going to, and especially in regression, labels are important. For example, if this is a data set for the humidity, the temperature, the minimum temperature, maximum temperature of the day, and also the date, yeah, and also the whether it's rainy, mendung, cloudy, thundery or storm and things like that. Okay, so what is wrong with this label is whatever data we have, we need to label it correctly. Then only we can use this data to predict, after a certain period of time, we can use the data to predict the next cycle. Okay, based on the next cycle, for example, if you are in December, usually we will get some monsoon, so we get a little bit more rain. So we can use the data from previous year and years to create that prediction. Okay, so the labeling is important. If we had taken this data around last month, so today is the 20th of September. So if we take data from last month, this should be the October of 2025, not December 2025, because we haven't got to December 2025 yet. So this data will not be accurate because the labeling is wrong. So what are label? Label is the value that we're trying to predict. So if you label it wrongly, then we won't be able to give the right output to the for our purpose. Okay, right. Regression predicts a numerical value. So using algorithms, okay, using algorithms, we have data from previous records, and then we use the model, which is the algorithm, involving mathematical modeling. So we use these algorithms and we produce the output, for example, the estimated temperature. Okay, so we use all these data that I've collected from the weather station, and then we key in into our tables. And this one is just an example. So this is like a very simple table, a graph. Okay, so but in real life, it will be more than one factors that we use to predict certain values. Okay, so machine learning is using mathematics as a model representation of the relationship between real world features. So they use the data that have been collected over the years, and then they put it into these tables, and then they turn it into the graph, and then they get the mathematical equation, and then they will use it to extrapolate, yeah, and find out what is going to happen in the next few weeks, few months, and few years. Okay, so then we go. Okay, so next we go to the next part of supervised learning, which is the classification. So classification is another specific form of supervised machine learning where the task is to classify items into similar categories. Okay, for example, is to classify a picture of noodle using a bowl of laksa or fishball noodle. Okay, so basically you look at the picture, you classify whether it's this item or that item. Okay, so you have got the categories of classes already. Okay, so or if a person is COVID positive or negative. Yeah. So in classification, label training data with matching output data and categories are required to train the model. Yeah. So a child in their early years can learn using supervised learning. For example, you show them images or real life cats and teach them, so this is cat. and that yellow one, that orange one is cat, and that spotty one is cat. So and the pointy ears is cat, and then they have different types of cats and different species of cats. So you show them all the different species, all different colors of cats, and you classify it as cats. So they will recognize it as cats. And then next you go to dog. So this one is dog, the Rottweiler is dog, the Chihuahua is dog, and that kind of thing. So then they will learn that kind of this kind of this kind of animal is a dog. So that is, you have already classified you've classified it in the first place, and you put the items into the classification. So uses of classification also include object detection of autonomous vehicles or predicting stocks to buy, hold, or sell. Okay, so you determine the classes beforehand before you put the items or the materials into the different classifications. Okay, so the more label training data used, the more accurate the model will be. Okay, so for example, if you classify pineapple, so you have different types of pineapple, different colors of pineapple, but it looks similar. Then the AI model will learn to be to recognize the different types of and different species of pineapple and categorize it accordingly. With the skin like this, and then got the crown like this. So it is a pineapple. So if even they see a slightly different color, but it's still similar in texture and similar in the crown. So they would recognize it as a pineapple. All right. So the same goes to the strawberries and grapes, right? Because you have got red, red ripe strawberries, and you got some with a little bit of greenish, or sometimes a bit of yellowish strawberry. So, but if the shape and with the seeds outside, and then with the green bit on top, they can still recognize it as strawberries, even though the color is slightly different. Okay, so the model quality is actually very highly related to the data quality. Okay, the more quality the data is, the better the model can learn, and therefore the output will be much better, right? So it will be generalized better and give more accurate output. However, in real life, in real world situation, there's no such thing as 100% accuracy, as we know. Right. So in classification, the trained model will produce a prediction of which class the new data belongs to. Yeah. So now we have already got the classification model. We have pineapple, we have strawberries, we have grape. So we put on a new data, which is the green round grapes. I can't remember the name of the grape already. But since the AI model have learned a lot of different colors of grapes, even though it's not the tiny one, it's not the purple ones, it's not the round ones, certain type of grapes are a little bit elongated. But still, if it's still it comes in that little bunch of grapes, or a certain type of shape, they still can consider it as grapes with 95% confidence level. Okay, of course they won't say it 100%, okay, because at some point there will be some mistakes here and there, according to the model and according to the new data that has been given to them. Okay. So at the fundamental level, it's good to know that a simple binary classification system, there are only two classes or categories. But if the problems become more difficult, there will be more classification, we have more labels, we have more graphs, we have more tables to put in. So it will be it will become more complicated. Okay, of course, you don't have to know all that. You just have to know that these are being used as to train the AI model to learn how to recognize some items. Okay, so this is the machine learning. In the supervised learning section, they have regression and classification, where regression is a numerical value and classification is a non-numerical value. On the other hand, machine learning also uses unsupervised learning, okay, where the data is unlabeled, you have no categorization, you just find the similarities or relationship between the two, between the items. So they differentiate it using clustering and association. So it is almost similar to classification, but you do not classify you don't give the category beforehand. Okay, so you give a basket of fruits, so you need the AI to learn by itself to categorize it accordingly. So what they can use is either they can use the color, they can use the shape, they can use the texture. So they can use different ways to classify it, and it won't be wrong. Okay, it is not wrong. It's just that a different way of their clustering or their learning the data without being told, yeah, how to categorize it. Okay, so as I mentioned just now, in supervised learning, it's like you're teaching a child, you show the cat and the dog, and you show this is cat, this is dog. Okay. For in unsupervised learning, you give the child toys, some toys. Okay, some toys they are stationary, they are soft toys, they are vehicle toys, they are block toys. So the child will have to categorize it according to how they want to categorize it. Okay. As I said just now, they can categorize it using the color, the texture, the tires, whether they want to categorize it as stationary vehicles and blocks, or they can categorize it using colors. So the green one goes here, the red one goes there. So it is up to the model, okay, to the person to learn how to categorize it. Okay. And they can in okay. So in this example, you find similar data points and group them together. So you give the AI a group of fruits, a basket of fruits, and they will have to categorize it according to the whatever. Yeah, because we have not categorized anything yet. We have not given them any labels. Okay, so they can be grouped using colors, they can be grouped using shapes, they can be grouped using whether they are bunches or in singles. So sometimes then there will be unexpected results. Okay, especially when there are outliers. Okay, maybe some these are pineapples, grapes, and strawberries, and suddenly there's a durian there. Okay, so there will be outliers, and the system might not be able to recognize it. So they might have to change accordingly. So maybe they will go for colors. So if the colors, they can take the greenish strawberry and the green grapes and also maybe a green pineapple, and group it together, classify it together with uh, one durian because they are green. Okay, so that is how they can group, classify things together based on clustering model of unsupervised learning. Okay, but of course the model is will try to give the best grouping for the fruits, just like the recommendation by Netflix, the trending or the drama or K-drama, Bollywood, Hollywood, whether it's series or movies and things like that. Okay, right. So in real life, we also use unsupervised learning. For example, the movies we watched, the items that we purchased in shopping platforms. Okay, the shorts or the videos that we watch in TikTok, yeah, the reels that we watch on Instagram, yeah, and the list of songs that we listen to in Spotify. Okay, so these are the applications that we use in real life. Yeah, we have been using it and we don't realize we are using unsupervised learning in our daily life. Okay, so how do they go about creating or developing the cycle of this learning and data entering and producing results? So they have this business objective or something they want to achieve, and then they gather data, and then they prepare the data and clean up and organize it, and then they explore the analysis of the data. So they analyze the data and then they explore and they build models and then they evaluate that model and then they deploy that model and they see if it fits their business objective. Okay, so for example, you want to get people to see the Shopee developer, they want to get people to buy something. Okay, so they see how is the buying trends, yeah, in a certain group of people, and then they gather the data from that group of people, and then they prepare, clean up, and then they explore, then they analyze and explore the data, and then they build the model. Which one will suit the buying preferences for this kind of people, and then they will evaluate by trying it on and as what do you call that, as pilot basis, and then they once they've received some input, some results, then they will start to create a bigger model and deploy the model into a bigger platform, or maybe use it as a main way to look out for buyer preference, and then if that fits the objectives, they will keep doing it and improve it. Or if it doesn't fit the business objective, they might have to change a little bit more or gather a little bit more data so that they can get a more accurate representation of the population they are working on. Okay, just like I said just now, they're looking on to find out what the buyers from the age of or working age, for example, 25 to 65, but it is maybe too broad for them. They don't want the ones that are not maybe the younger ones which have not climbed up the career ladder yet. So they might want to reduce the number to 25 to maybe about 40 when they, because after 40, most people have started their career, climbing up the ladder of the career. So they would, group it in, this is an example, 25 to 40. And then 40 to 65, they will create a different algorithm for what kind of things that these people would want to buy, the preference of these kind of people. Okay, now we've gone to deep learning, okay? And it's 10 o'clock. I think we will do one more because the next five, I mean the second five is actually quite quick and easy. So we'll do the next part, number 5 until 10 in the next half, okay? Right, so we go to deep learning now. We have this, you can use this QR code to go to quickdraw.withgoogle.com. Okay, because we want to show you how actually we find these things. Okay, let me just see if I can get to this website as well, and we will show you. I will try and show you in the screen as well. Quick draw. Okay, let me just change my screen because I've gone to quick draw now. Let me see if there is sound. I'm going to share with sound. Okay, okay. So then we go to here and you just go to let's draw. Draw ice cream.
I see triangle. Oh, I know. it's ice cream.
Okay,
Oh, I know, it's rainbow.
that was quick.
I see line. Or stitches. Oh, I know, it's ladder.
Okay,
I see mushroom. Or cloud. Or ceiling fan. Oh, I know, it's fan.
okay,
I see circle. Or moon. Or blueberry. Or potato. I see door. Or cookie. Oh, I know,
ah,
it's donut.
it's taking longer than I thought. Oh, now I know.
I see golf club. Or broom. I see sword. Oh, I know, it's ceiling fan.
Okay, so um, the website actually figured out all of my doodles. So let's see one item and see if we can see the other 50 million drawings made by other people in the world. Okay, so okay, this is maybe too small. That's why I've done it a little bit bigger, they might may look a little bit better. Okay, so these are all the examples that have been drawn by other people, and this is how they learn that by doing this, they even um, closest match is like the moon, the cookie. So it's very similar to that as well. So they will give some examples. So this is how they learn, by data being input by other people as well. So it's actually not they learn by themselves, but it's by data that is being put by other people. And also we know, like when we use ChatGPT and things like that, we need to be careful because some of the data is not the real data, but the input that has been given by other people. So if they put it incorrect data, then we might be exposed to a inaccurate data as a result of other people's input. So sometimes it's good for us to provide more accurate data, for example, in our articles on the internet, in the newspapers. If they give good data, then the artificial intelligence will extract this kind of data and use it as an answer to our questions. Okay, so I'm just going to share this with you. I'm no advocate or no promoter of uh, Apple. Okay, so it just shows to you that we have been using some artificial intelligence in our daily life, even in simplest term. Yeah, for example, our unlocking our phone, even using whether it's using facial ID or fingerprint or thumbprint or things like that. We are still using artificial intelligence to be utilized in that sense. Okay, so now we go to the next topic, which is the deep learning. Deep learning is algorithms that can learn patterns in big data over time and also commonly known as neural network. Okay, When we learned about machine learning earlier, it was a simple, much simpler mathematical equations, much simpler patterns, much shorter time. But in deep learning, they created algorithms that learn patterns in big amount, in big data. So, and sometimes in multiple layers. Okay, so this is known as the neural networks. Modern AI is actually inspired by human brain. Yeah? So this is how the neurons look like. Okay, this is human neuron look like this. Okay, the neuron are individual cells which are connected to each other by synapses. Synapses are the gaps in between the two, between the neurons. Okay, so this is brain cells. So the synapses are gaps that can transfer the electrical impulses faster, and also the loss of the synapses are the things that make us becoming more slower in our memory, in our thinking, in our reflection and things like that. Okay. The human brain has about 86 to 100 billion neurons and 1 trillion synapses, yeah, because each cell can have a couple of, a number of synapses in between this and also another set of neurons. Okay. And the figure on the right is example of artificial neuron. Okay, the artificial neuron has a collection of weighted inputs. They are often summed together. So these are the inputs, and these are the weightage of the inputs. So we will learn about it a little bit later. It might be a little bit difficult to understand, but it doesn't really matter because we try to make it easier for you to understand. Okay, so in machine learning, the workflow is maybe a couple of layers only. One input, one feature extraction, input into machine learning model and give an output. However, in deep learning workflow, the input are vast and they have a huge network of model to create an output. Okay. So this machine learning process is much simpler than this one. Okay. Then we will see, right, let me just see. Okay. Okay, so deep learning uses layered neural networks to automatically learn complex patterns from data. Okay, so we have a neural network, an algorithm, okay, a deep learning algorithm, okay, which has been produced by the scientists for this company. So what they need are the data for a certain, they want to determine the price of certain piece of land. Okay, so this company provides the algorithm to find the right price. Then they will have to get some data. Okay, the size, okay, how much is it per square feet? And then the distance from city center. So the distance from city center, or from the main facilities. So then they will, the closer it is to the city center, maybe the price is higher. Yeah, for example, the price of a piece of land near London is much higher than the price in somewhere in the Manchester area, or maybe the Sheffield area, or maybe the Whitehaven area. So it's a bit north, and also it's a bit in the middle, which have less facilities or big towns around it. Okay, so maybe they also need data of the distance from transportation hub, because people want to use public transport. So the closer it is to transportation hub, it's much more expensive compared to the one that is further away, which you need to use a car or your own transport to get from one place to another. The crime rate also can become a factor. So it depends really on what actually you want to achieve from the algorithm, and also what factors you want to put in. So these are the inputs which will be put into this algorithm. For example, size, okay, small size, medium size, large size, extra large, okay, and then different from city center. So different from city center also, if it's distance, this one is maybe they put 5 kilometers, and then they have into small size, medium size, large size, extra large. So then even distance from city center might have a couple of data inside there. Okay, so 5 kilometers, 10 kilometers, 20 kilometers. So they will feed into this separately, and then they will go to a different layer. So what about if it's size and distance from transportation hub? Size and crime rate, distance from city center and crime rate. So these different algorithms will be working to find out the exact price of the piece of land in a certain area. Okay, so this is how they try and get the output based on the input that has been given. So if you're given this huge set of data, the computer will break it down, okay, to different layers. For example, the size, small, medium, big, large, and then the distance, 5 kilometers, 10 kilometers. I mean, according to the developers' developers' setting, and also based on the end user's request. Okay, so if the company say they employ somebody to do it, so that the person does it, and then they will do it according to the request of the owner, and they will, and then they use the data and then input the data into the system, and then they will produce the results. So if they they're not requesting all these things, so the algorithm will be a little bit more different. Okay, so it will be different from this one. So let's say they take off the crime rate. Okay, because there in that country nobody commits a crime, so the crime rate will not be relevant there. Okay, so then it will become these three other factors that have to be put into the system to get the price of that piece of land. Okay, and what do we use deep learning for? Okay, we use it for our autonomous car, okay, or smart car, the car that drives itself, autonomous food delivery robot. In Mama's restaurant also now we have autonomous food delivery robot, and also drone in agriculture. So you can set the drones to go to a certain location. You can set it into the system of the drone to, let's say, spray pesticide in that area. Okay, that can help to use can help to reduce the use of human, and also reduce the exposure of the human to the dangers of the pesticide, or the dangers of spraying the fertilizers, and the dangers of possibly inhaling the fertilizers and causing damage to the lungs. Okay, so these are a few of the deep learning applications that we use. Maybe not every day, but some of us use these applications in their daily lives. Okay, so to conclude, these are the type of the key differences between AI, machine learning, and deep learning. AI is the broader concept of intelligent machines. Machine learning is a branch of AI focused on learning from data, But deep learning is a subset of machine learning that uses neural networks to learn complex patterns and solve more advanced problems. Of course, it uses more data, it uses more neural networks, more algorithms, and it will be more complex, but the problems that it solves, the more advanced one, it can give you more accurate and also can produce better results for the purpose. Okay, so I think now we will take a break before we continue on to the computer vision. It's almost 10:30. Okay. Right. So we will have a 15 minutes break. Okay, so you can go and have a cup of coffee, and then we can meet up. We can meet back here at 10:45. Right? So just give yourself a break and just go over the items that I've shared just now, and see if you can understand the basics up to deep learning. Later we'll learn how the computer sees and how what is the uses of AI in our daily lives. Okay, so is Prof. Aspa, are you around? Let me just stop sharing for a while. Okay, so since Dr. Aspa is Aspa, are you there? Right, it's all right. So we'll go and have our break now, and we will start in 15 minutes. 10:45 we'll be here. Okay, thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, kita kembali lagi dalam second half setelah kita mendengar empat tajuk yang telah dibentangkan oleh Dr. Jannah Tumandiha Abu Bakar. Kali ini kita akan continue dengan 6 topik yang lagi menarik dan lagi canggih. Tanpa membuang masa, saya invite Dr. Jannah. Dipersilakan.
Okay. Alhamdulillah. Hopefully everybody has got a good break. And we're going to continue with our next topic of the day. All right. So we are now going to computer vision. You want to learn how a computer actually sees. Yeah. Okay. So there are a lot of a lot of application that is that we use in our daily life that involve the ability of the computer to actually see, right? For example, the privacy protection of a CCTV, COVID prevention and control. During that time, we can actually measure the distance between one person to another and see how many people are there in a certain place. And smart monitoring, we use the CCTVs being used in airports, in shopping malls, especially during COVID. They can even use a CCTV with infrared thermometer, temperature monitoring to find out which of the if there is any of the passengers or the customers are actually having fever. Okay, so and we also use CCTV in highways. So if you realize that actually in Malaysian highways also, they also install CCTV to monitor the traffic and also to monitor the as a timely monitoring of the traffic in the highway. Okay, so how does a computer see? Right. Computers actually see in black and white. Okay, they don't see the way we see things, but it is similar to what we actually as human beings see, but that will be a little bit medical. So we'll just stick to the computer vision. When there is a picture, there will be one, and if there's no picture, it will be zeros. Okay, so the number one, the digit one you see here, let me just find my mouse. Okay. Right. Okay. The digit one you see in this grid here, where you see the number one, the computer records this as one. Okay, where there is no image, the computer records this as a 0. Okay, so this is a 5 by 5 pixel square, so it is 25 pixel square. Okay. Okay, these pixels then will be arranged vertically, okay, to become vectors of ones and zeros, okay, or zeros and ones. And this is used to train the neural network, which is here. Okay, the neural network here that have layer that will have an input layer of 25 nodes. So these are the nodes. So each box becomes the nodes. And if you have and you have the set algorithm, which we are not going to go into in detail, then you will have a weightage of the what do you call that? The from the vectors. Okay, they will go through this algorithm, and then the output will be whether it's number 1, 2, 3, and whatever. Okay, so from the image, after they change it into a vertical node, they put it into the algorithm, and the algorithm will recognize it as according to the position of the zeros and ones. It will come as an output of number 1 with the confidence of 90%. Okay, so sometimes the picture will be a little bit distorted. That is why usually it is not 100%. Okay, so if we if we have 4 nodes here in which they have different weightage or algorithm, then we have actually 100 weights. Yeah, in here 25 times 4 is 100. So and then we can have more nodes, more weightage, and those different weightage will give different ways as how to the computer sees it. Okay, so of course this will include a lot of setting, a lot of algorithm by the machine developer or the computer developer, and then the outcome will be the number that or the image that we see in the first place, right? So this is just a simple 5 by 5, which is a 25 pixel image. Let's say today's camera is about 24 megapixels, so it will be like 24 million pixels. So then it will be like a few million here and a few million here. Okay, so it is a huge amount of data, and the more pixels they have, the sharper and the better image that they will produce. Okay, so since it's a little bit technical, I'll just show you a little bit so that you understand that they don't see it number 1 as number 1, but they see it as a vector of zeros and ones. Okay, let's remove the number 1 because it gets confusing. Okay, see this image of a bottle, right? Image of a bottle. So where the computer sees the bottle, they will put 1 there, and where there's no image of the bottle, it will be 0. So then it will capture into a vector, and then the vector will be put into the AI model, into the model, and then they will produce the output, which looks or shows the same thing as the bottle. So if the bottle has got color, so it will have different layers that produce different colors and things like that. So there's a lot of work is being done by other people that we are only here to utilize it. So it is something that we should be grateful of, and it should encourage us to learn more about this so that we know that these things can develop, these things can change, can evolve in the future. So there are more things that we can do with our knowledge and can do with our lives. And rather than just sitting down and just using it, we can do something better and add on to the quality of education, quality of life for the society. Okay, so now you understand how the computer sees and be trained how to recognize it. Now we will discuss briefly the common computer vision system in our offices. Also known as, the usual one is the facial recognition and trace system. Okay, The vendor will train the neural networks with millions of pictures of faces, which would generate a unique ID per face. Okay, so if you have a lot of you have these millions of faces here. Okay, and they put into they put into model, so they train the model to extract the features, and then they use it to classify each face to become a person's unique ID. Okay, so how do you do that? Okay. Once the model has been trained, it will be deployed to the office entry system. Then your company will ask you to provide your latest photo. Okay, so you give the latest photo, and then the photo will show neural network and your unique ID of with the vector, and then the name and the code. So whenever you go and go to the office, then you show your face, and then the computer will generate a vector. So if the vector is similar to the vector given to you in the first place, then it will be a match. Or if it's close enough, it will be a match. Then they will let you enter. Okay. For example, you have done, you met with an accident and done a plastic surgery, so your face has changed a little bit. Probably your nose is a bit crooked or your eyes are a bit more wider. So they will see if it generates a vector that's not far from the real vector, from the original vector that has been produced for you by the system. Then if it's close enough, then you are allowed to enter. But if it's not close enough, then you will not be allowed to enter. So you need to go back to your HR and ask them to get the vendor to correct it for you. Okay, so here it goes again, the facial recognition from untrained model. So they put the data in and train the model to create a 128-bit vector. So each person will have a unique 1 to 8-bit vector, and once you have had the ID assigned to you, then whenever you come in, you scan your face, and then they see, oh, is there a match? Then you will be allowed in. If it doesn't match, then you will maybe try a couple of times. If it doesn't let you in, means that there's something wrong somewhere, and then you will need to go and see call your HR or security and things like that. Okay, so this is how a computer see, and this is what how they use it to use it in our daily life. Okay, similar goes to how a computer hear. So from transcribing audio into text. So for example, a simple word of hello, they will divide it into 20 millisecond slices of audio. So there will be a few audio files, a few slices of audio files, and then they will change it into vectors, so zeros and ones again. So from this vector, they will put it into the AI model and train it to recognize it. For example, this word hello, they will slice it into different audio, so they will arrange it and they will put it into the train model, to the model to train them, and then they will recognize it as hello. Okay, so the next time somebody else says hello, then if it is similar vector to the ones that they've created before, then they will recognize it as hello. Okay, or something similar. And sometimes we need to use a dictionary to add on to the different slangs, different ways of people saying hello in different parts of the world. So if it's similar to the hello base vector, then they will recognize it as hello as well. So this is how our computer learns how to transcribe it into text when we use our transcriber. We use NVivo in our qualitative experiment or data collection and things like that. So we can, this is how a computer hears. So basically they use mathematical equations, again, vectors and numbers, yeah, to be able to differentiate between the different types of different words and different sentences. Okay, right. So next we go to the large language model. Okay. Foundation models are the versatile cores of AI. So we train the foundation models for to adapt for for multiple tasks, right? So based on the data that we have from the text, images, pictures, the structured data, and all the signals that we have. So we have it as our data. So we perform training by using the foundation model, and then we adapt from the model, we adapt into different tasks such as question answering, sentiment analysis, information extraction, image captioning. So now you have, when you take photos, they will also suggest a caption that's suitable for that, object recognition and following instructions. Okay, so based on these models, they are adaptable to perform different tasks that if in different in previously we are not able to do. Okay. And large language models are basically learning the learning process of a machine, and it is learned by tokenization, where it breaks down the text, the text into the smaller bits, just like we did just now with the audio and the picture. We change it into vectors. The audio also we change the vectors. Now the language models, they use the sentences and they break down the text into bite-sized pieces that the machine can understand. Okay, so there are three types of tokenization that we will discuss in a little bit later, but the tokenization types are word level, where they split text into the individual words. So from let's learn about tokenization and how LLM works, they divide into let's and learn and about and tokenization and how and LLM and works. Okay, and then we have the character level, so where they treat each character as a separate token. So L is a token, E is the token, T is a token, and the third is subword levels, where they break words into smaller units. For example, words with addition, like the tokenization, so they break it into token and ization. Okay. Then the tokens will be, okay, so then they will be changed. Okay, they will change it into vector. Okay, so now they have split it into different tokens. So then they will change it, they will convert it into vector, again numbers. Okay, so different words, different tokens will have different set of numberings. Okay, I also not sure what these numbers represent, but it's just a token of this sentence, and they convert it into these vectors. So and it is they break sentences into these different words, and also they clean up the data by removing words like is, this, to reduce the number of such words, right? They apply stemming and lemmatization to get the root word. For example, this tokenization, they split it into tokenization, and once the data is clean, then only they can apply the algorithm. Okay, we'll see about the algorithm, the vector, a little bit later, but now we learn about embedding, where they decode multiple meanings in language model. So some words can mean different things. Okay, so it is important for us to, for the developers to make sure that, the computer understands that the cool in the first sentence, that guy is cool, is not the same as I need something icy and cool to quench my thirst. So the first one is like the personality or something, but the second one is the physical character of the something, or the item. Okay, so when they do embedding, so they will breathe meaning into the words by using numerical presentation. Okay, so the word cool in the first sentence is related to the character of the person. Okay, like awesome, stylish. So it will be placed into this area of vector, and the different the second type of cool is the physical representation. So the cool, refreshing. So it will be put here in this vector. So this is the vector. So the vector here and the vector here will be different, will be of different values. Okay, so that is how they will embed and do different and find different meanings and decode the meanings differently for similar words, but have different meanings. Okay, so how do they do this as a vector? Okay, this is quite interesting, because you can apply mathematical equations to a word. Okay, and it can become mathematical vector. All right. So researchers have developed algorithms to convert text to vectors. There are several ways for words vectorization that we won't be covering in this talk, but I'm just going to share with you a little bit. For example, okay, for the word dog, the vectors are this first line. The word puppy, the vector is this line. How do they get to that? Okay, so puppy and dog is similar, all right? So that's why the vector is similar. Okay, puppy is a baby or a young dog, so the vectors are similar to a dog. Cat is an animal. It is similar, quite similar to a dog and puppy, but it's not close enough. So it is a similar vector, but a little bit further away from the puppy and dog. And houses, on the other hand, it's a totally different thing. It's a different set of vector. So it will be different from the animals here. Okay, same goes to the second example. Man and woman are the different the genders, so man and woman. And then we have king and queen, which also king is a man and queen is a woman, but it's a different vector because the king and queen is a title. Okay, but it's a title for man and this one is a title for woman. Okay, so it's a different vector. So depending on the algorithms, they will put man and woman together and king and queen together at a similar vector range because they have similar properties. Okay. And then once we have converted the words into vector, they could do it as man and king here, woman and queen here, but it's just the way that they do mathematical vectors for words in computers. Okay, so if you want to do it man and king in the different in the same vector, similar vector, and woman and queen in a similar vector, then you have to make your own computer lah. Okay, so once the words are converted into vectors, we can do vector mathematics. For example, king minus man plus woman equals to queen, right? So king minus the gender part, so now it's only the title, and then you add the woman part. Okay, so now it's the king but female, then it becomes the queen. So it's just something that we are not aware of, but once we listen to this talk, we know that that can happen, yeah, in computer world. Okay, so transformer is a special type of neural network. I just want to show you this because you don't need to memorize anything about this. But this one is involve a different type, different level of mechanism where it understands the whole paragraph or the whole article at once and summarizes or grasps the context of the input. Okay, so this one they work with a bigger set of data input, and they extract the important things, or they extract according to the algorithm or the prompt that we give them what we need, the purpose of the purpose of the study, the purpose of this item, and then they will grasp the context to be of the input. Okay. For example, this sentence, yeah, the cat sat on the mat because the it here in the transformer, okay, in this what they call the transformer is this model. It acts as a highlighter, okay, marking important words or phrases. So there is the feature within the transformer that acts as a highlighter. Then it helps to focus on key parts of sentence for better understanding. And from these key parts of a sentence, that gives you the ability for them to summarize, to extract the important key points and things like that. Okay, so for this sentence, to complete the response, they will give a list of the possible words and estimated probabilities. Okay, so if the cat sat on the mat because it refers to the mat, so then it must be comfortable. The most suitable word is comfortable. It can be soft, yeah, it can be nice, can be warm, it can be lovely, but the most suitable word for this one is is comfortable. So if you are thinking about understanding why how that a computer can do, an AI can extract information, can summarize an article, this is the way that they do it. Okay, and because of the algorithm that has been produced by the scientists, by the tech people, that makes us able to utilize it. So that is why we now have the ability to utilize this AI technology and use it for our own perusal. Okay, so what are the applications of Gen AI? What is Gen AI? Generative AI or Gen AI are algorithms that can create unique content by learning patterns from existing data and generating new inputs based on that knowledge. So this is quite recent, from 2014 onwards. Okay, so more than 10 years ago already, generative AI has been here in the world. It's just that whether we know it or not only lah. Okay, or maybe we're not exposed to it, but it has been here for quite some time already. Okay, so AI is not new actually. Okay, if we realize that it's not new and it has been here for many years, it's just that people are using it a little bit more because more people are using smartphones, more people are more aware, and more people are using it on a daily basis. Right. So some of the applications of Gen AI, text to image, so we can create images using Bing. Okay, Microsoft Bing can create image. We can create image. Meta AI, we haven't got it in Malaysia yet, but we have Bing, and also we have a lot of other applications that use able to utilize this function, text to image. Even Canva can use text to image. ChatGPT nowadays also can use text to image. Okay, so other applications of generative AI is text to music. So we can go to suno.com/create. So we can put in our own music, our own lyrics, and then we give them prompt for a type of music that we want, and then we can create a music of your own. Let me just share with you the one that I've made using that using this one. Okay, let me just
Wake up world, it's time to learn. Knowledge waits at every turn. In this room where dreams ignite, innovation shines so bright. Open minds and hearts unite. Together we reach new heights. Unlock the code of what's ahead. Forge new pathways where we're led. Rise and shine, the future's here. Trade your doubts for something clear. In a world where change is fast, plant your dreams and make them last. Step by step we shall explore. See what AI has in store. Every challenge we embrace. We're reshaping time and space. Guiding lights will be the torch, helping minds to seek and forge. From ideas we'll never part. Every lesson fuels the heart. Rise and shine, the future's here. Trade your doubts for something clear. In a world where change is fast, plant your dreams and make them last. Guiding lights will be the torch, helping minds to seek and forge. From ideas we'll never part. Every lesson fuels the heart. Rise and shine, the future's here. Trade your doubts for something clear. In a world where change is fast, plant your dreams and make them last.
Okay, so we actually there's a lot of song on the internet already by produced by AI, including the latest song "Justice for Zara." So it's actually an AI done by AI. So and sang by AI. So it is something that we can use and utilize for a better for a greater good. Okay, it doesn't necessarily mean that AI we can only use for bad things. Okay, so we can use AI for good things as well, because we need to flood the world with positive and good things rather than the negative things that is already circulating. Of course, you can do artificial intelligence, you can use technology for good or bad. So it is up to you actually, right? So the next application is text to podcast, where you can actually use application to convert text into podcast. For example, you have an article that you don't really want to read, or you want to know you want to you study better by listening to conversation or something like that. So you can actually use notebook lm.google, okay, and you upload your article or your textbook and things like that, and you can then convert it into podcast. Let me just give you an example for this example of this podcast here.
Think about getting a pap smear. You know, you go through it and then comes the waiting.
Yeah.
Sometimes it's weeks, right? Especially maybe in bigger healthcare systems. And that wait, well, it can cause a lot of anxiety.
It really can.
But what if?
Mm.
What if we could cut that time way down?
Yeah.
And maybe even make the results more accurate?
That's exactly the goal.
So today we're doing a deep dive into some really fascinating research. It's all about using computer image processing to automatically analyze pap smear images.
Right. And just for anyone maybe less familiar, the pap smear itself is such a critical screening tool for cervical cancer.
Absolutely.
Okay, so those are the kind of things that we can use to help us in our day-to-day life. Say we don't have enough time to sit down and read because we need to travel to that conference and things like that. So what we can do in the meantime is actually listen to the podcast that has been developed from the text that's been uploaded into the website, into the application. Okay, so that also you can use, can utilize the technology for your own good. So you have no time to prepare. You just upload the items into your notebook lm.google, and then you listen to it whenever you are in the car or doing something else, but you still can listen to the podcast. Okay. So another application is text to video. I'm sure there are some of us that are already using text to video. This one is the earlier versions of the text to video applications. And now they're developing more and more applications. So it is up to you to use which one. You can go to this website, www.dis-id.com, and try it on yourself. I'm not going to share this one because the link for this video is actually expired already. This is from AI Singapore. But you can produce your own videos by either this one, or you can go to our next workshop, which is the video scripting on the 27th of September. You can go to the TASPA Center onpay.com to book for your slots there. And okay, so these models are shaping the future of AI, and there are more and more coming. Okay, this slide was made in 2024. So in 2025, there are a lot more. DeepSeek from China is already, part of the AI model. So there are more applications that are being developed, for different various purposes. So AI is developing. If you are not here, if you are not in the system, you have not in the usage of technology, then you might be left behind. Okay, it doesn't mean that you must use it. You have to know that it is there, and it is going to be part of your lives, and it is going to be helpful in some sense, and it can be some negative impacts, but there are some good in it. So it is up to you whether you want to use it for good or for bad. Okay, so however, comparing top language models across key capabilities, in 2024, Claude 3.5 is actually the best for language models, but of course, this will change in the future, and it keeps on changing. So people keep on creating more and more, developing better applications, better algorithms, and things like that. Okay, so let's learn about the impact of generative AI. So you can go here to this QR code and have a go at the impact of generative AI. Right, so today we're going to cut time short, so we are going to let you do this at your own time, because it only lasts, the QR code only lasts for 2 days for Mentimeter, and so if you want to try it, you can try it within the next 2 days. Okay. Right, and other positive impact of generative AI. So we have a negative, positive. Of course, we have positive, and of course we have negative impact of AI. Okay, in positive impact of AI, actually it can enhance production and efficiency, where you can use artificial intelligence to summarize documents, you can generate slides, you can do key points extraction. We have a lot of things that we can reduce the time of doing so by using AI. Okay, so in this slide, we have a product document summarization, which can be used especially when you have a lot of documents to summarize, and you have read the documents and you know what you are looking at. So again, you still have to monitor your documents, right? So you you already know what you're going to do, and whenever the technology summarizes it for you, you just go over it and check whether they've got the right thing, they've summarized it correctly or not. Okay, that is our duty as a human being to check whether the technology is doing it correctly or not. Same goes to the QC that is being done in factories and things like that. So you need to have a person to look at the whole production, the sample of productions, to make sure that the production is being made up to a certain standard. Okay, even nowadays they can use AI technology to do that. They can scan the item and see whether it meets the sizing or measurement requirements and things like that. That can also be done, but you need to have some input from the actual person who actually knows how to differentiate between the good product and the not so good products. Okay, slide generation also can help us to reduce our time. So by using artificial intelligence, they will create slides for us. So it is up to us to just maybe adjust a few things rather than spending so much time to produce, to create slides and to think about what are the designs and things like that. Even in AI also, in PowerPoint also, they have also recommendations of the design of the slide. Okay, so you can use your pictures, you can use their pictures. There are stock pictures that you can use to help you with creating the slide or generating the slide. Therefore, the work can be done quickly. So your work is you can focus more on other things that's more important, and to focus on more creative and strategic tasks rather than these secretarial or paperwork and things like that. Okay. Another positive impact of generative AI is learning aid. So you can you can convert your textbook or your notes into a study guide or audio version of the notes or podcast. For some people, they prefer it to be a conversational thing. Then they can use it to revise their documents. Okay? They can use it to revise while they are commuting to work, while driving. So it can mean a whole chapter of the anatomy of the heart, for example. Okay, so it can be done during our commuting. I mean, 1 hour commuting to work and things like that. So it can save a lot of time. Okay, and sometimes the time you don't have is the time that you can use you can utilize while you are doing other things as well. Okay, because some things you don't really need your brain to do that. For example, when you are sometimes when you are driving or you are in public transport, you are not the type that can read a book or read from your device, but you can listen to it. So it will help you to make full use of your time when you are not able to do another thing, but you still need to be there and to sit around and do nothing. But in fact, you can do something while you are waiting or while you are commuting. Okay. Then of course, there's nothing perfect in this world. Generative AI is not spared. So there are also limitations when using generative AI, right? For example, in the earlier version of ChatGPT or the free version of ChatGPT, they will only take certain references from maybe 10 to 20 years back. So it is not the updated version. Okay. Or the data is not up to date, then you still have to do your own research again. But by using technology, you can reduce the time. So let's say they provided you with the articles or the references that they have looked up, and then you just need to go to that website to see whether it's legit or not. You have to see whether the if they include a document, whether the document exists or not. I mean, it reduces a lot of your time rather than to start from scratch. Okay. When we're creating images, also the image that we want might not be the one that generative AI produced, because they produce according to the prompt and the database they have got. So the more data they have got, the better the images will be. But we'll go through that a little bit later. But now I'd like to share with you the negative impact of generative AI. Of course, there is good and bad in something. Okay, whether the bad one is something that you can brush out, or you can dampen it by increasing the good in it, or something that we need to ponder upon. Right? So there are negative impacts of generative AI as well. For example, deepfake videos that have been circulating around, can create tension and can create instability in certain countries. It can create arguments. It can create war between two countries or even two persons. Okay, so even within two people also, they create this deepfake video saying things about the other person which is not true and things like that. This unfortunately, there is not much that we can do because it is there. People can use it for good, but you can use it for bad. And nowadays also people are using influencers, somebody of a figure, somebody of a name, and use it to advertise their products, which may be fake, which may not be as good as it claim it to be. But since they use the videos or the deepfake videos of somebody that is known to other people, then they will be able to sell their products, which is, of course, it is not right. Okay, it is wrong for people to do that, to utilize artificial intelligence to trick people, to make a fraud claims and things like that. Okay, and also there are issues over deepfake porns, which is can be done using AI images. So it is basically up to the authority with how strongly they feel about it, how far they want to take action into these legislative actions into these kind of activities, and how are we going to prevent it from happening in the future. Okay, so basically, if we know that it is wrong, then we don't do it. But how do we tell it to other people? Okay, some people can just do it, because they just want to create difficult lives for other people. So we don't know. So but it is us who needs to educate our children, our family members to not do things like this, even though you might be paid handsomely, or you might be creating something beneficial for your own self, for your own good. But if it creates something that is not good for other people or for the country or for the world, then why on earth are we doing it? Okay. Another negative impact of generative AI is task displacement. And because of artificial intelligence, office jobs are now more at risk. More tasks are being able to be done by using artificial intelligence, and to be done using only maybe less number of human workers. The shopping malls are using counters at self-checkout counters. The airports are using self-check-in counters and things like that. Okay, and will AI upend white-collar work and consider Hollywood editor? Okay, where AI can be used for editing purposes, but of course there are some places, some countries that can still use still need of human workers, because AI in that language is not available widely yet. Okay, and it brings us to the next game, which is real, which you can go through whenever you are free. So you can snap this photo, all right, and go through it whenever you are free. So this actually shows you how the AI image can have not much difference from the real from the original picture nowadays. Yeah, and it's becoming more and more real, and especially those who have fewer exposure to artificial intelligence, they might be taking it, might be gullible to it. Okay, so it's very important for us to understand, the gravity of the situation. Okay. Okay, so what do you see in this image? This is some of the limitations of generative AI. Of course, this one is actually the slides are created in 2024. So at this time, the generative AI is still fairly new, and there is a lot of mistakes that's being done, and a lot of anomalies in the images. For example, the hand here, right? So an extra hand somewhere, extra limb popping out from maybe from from the back of a person, or three legs and something like that. Okay, context awareness. Okay, so it might be your image generated by this one. The first one is generated by generative AI, and this one is generated by Bing. And it's our responsibility to check whatever we put on the internet, whatever we created, we check it again and see, there's no way that satay or I think this is supposed to be satay. It looks like lokching to me at some point, but I think it is meant to be satay. And satay is not placed this way. No way you can, you put satay standing up like this. And also, why on earth are there sticks in teh tarik? Okay. So this photo might be, good enough for you, but having a meal with Merlion and this, I can't remember the name of this building at the back. So it looks, it looks nice, and I wish I was there kind of thing, but with this anomalies of the contextual awareness is not there, then it will be, this is so fake, so I don't believe that you were there. Yeah, so it's up to us to ensure that the generated images fulfill or adhere to certain codes of conduct, cultural sensitivity, religious belief, and etc. Okay, and as creators and users of AI, we should be mindful in creating or generating using generative AI. Okay, and sometimes generative AI can hallucinate. Okay, they can create things that is not there. Yeah, durian char kway teow might not. I mean, it's not kway teow, and I don't think people eat kway teow with durian. I don't know if they do it elsewhere, but I don't eat kway teow with durian. And nasi rice probably, but kway teow not yet. I might try someday if I can find durian now. But the kway teow is not kway teow. So I mean, there is a different, based on the database that they have, they will create according to what they believe that it is. Okay, so we as a human being, we know that it is not right, and so we need to check this out and go do another prompt and create another image. Okay. Right. Can AI be dangerous? We have been watching movies like iRobot, The Terminator, and recently there's a movie called Atlas, which portrays AI who evolved and think like human. Okay. At this moment, AI is still very much a pattern recognizer and will perform tasks according to the algorithm they are programmed with, right? But when they are programmed to do a certain task, they can be more accurate and perform much faster than human with less mistakes, increase accuracy, increase speed, and they don't need 6 to 8 hours rest like humans. Okay, but we have to understand that AI cannot work well if data is bad data. Okay, garbage in, garbage out. Okay, inaccurate data can cause AI to be less accurate at making predictions. Okay, and also the data can be messy and very difficult to organize. So in UNESCO, where they did a digital learning week in September 2024, they actually emphasized the importance of using AI ethically and responsibly. Okay, then it's important to use AI as the augment, to enhance, to boost, rather than replacing human judgment. Okay, and even though it is, there's a lot of negative impacts, a lot of negativity towards artificial intelligence, I'm sure this rapid development in generative AI sounds very exciting, isn't it? Right? So the last, I think this is the last one. For UNESCO Embodied Ethics for Students, is actually what is in the UNESCO meeting seminar that I've showed just now, but you can have a look at it, and basically it just lines out what are the principles of ethics while using artificial intelligence. Okay, now we are coming to the final topic of the day, which is AI jobs and me. All right. So we have been shown how useful and powerful artificial intelligence can be. So where does that bring us? Okay, what does it lead to? Will AI replace me? Will AI replace us? Okay, what should we do to become relevant? What should we do to remain relevant? Okay, I hope by now you have appreciated how AI works, how they learn, how they see, how they can be used to do a lot of things, good and bad, But of course, then I believe that you will always do the good parts. Okay, so humans versus AI. In a study, or in a study or in a survey done by 20 top lawyers in I think in the US, these lawyers are being given a document, NDA, non-disclosure agreement, to spot issues, to find mistakes in that document. Okay, and they are being compared with the use of AI to do the same thing. Okay, the results were the 20 top lawyers were beaten by legal AI. Here are their surprising responses. Okay, and AI achieved an average of 94% accuracy rate, higher than the lawyers who achieved an average rate of 85%. The lawyers took an average of 92 minutes to complete the NDA issue spotting compared to 26 seconds for the AI. Okay, the longest time taken by a lawyer to complete the test was 156 minutes, and the shortest time was 51 minutes. Can you imagine what other other things that the lawyers can do while checking the documents? You know, rather than sitting down looking at the documents for 2-3 hours, right? They can do other things as well. So one of the lawyers, Ms. Samantha Xavier, mentioned that as for being automated, I think this would help clients in getting better pricing and allow lawyers to focus on more complex projects. However, I think the test and AI technology must be very thorough to accomplish this. Okay, so it will be this is a competition between AI and lawyers. Okay, but now it is not that. No, we are not letting the AI to take over lawyers' job. It's just that the AI will help to do what lawyers need to do, and then the lawyers will then go over whatever is being checked by AI to make sure that it is correct and accurate, because it's already been corrected by AI. Okay, and then to make sure that it follows a certain set of rules. Okay, the legal side of it and things like that. Okay, if you're not using AI, then you will lose 3 hours of your time. So let's imagine these two lawyers, one with AI, one without AI. This lawyer without AI is sitting down, doing the document checking thing, and the lawyers with AI, now that he or she has got the AI helper, so they give the documents to AI check for 26 seconds, and then after that, for the next 3 hours, they can go and see another client, or do something more creative, or something other, the tasks that they need to do. They can build rapport, build network with other clients in the next 2 to 3 hours, compared to the ones that have been sitting down, still looking at the document, reading line to line. Okay, so this can apply to other industries as well. Okay, on the other hand, AI also creates new jobs. Sometimes the job is not even imagined yet. Okay, so content creator is a job nowadays, right? But you still have to have knowledge to do that. Okay, you have to have the determination, you have to have the knowledge, you have to have the ability, you have to have sometimes you have to have the creativity to perform that task as well. Okay, so it is not, it doesn't mean that, by using AI, you will lose everything. Okay, you can upgrade yourself, you can use AI to help you to do other things, and improve your skills and make yourself a better person, and can apply for a better job probably. Okay, even though that the check-in counters in the airports are already using self check-in counter, they still need people to service that item. They need people to be there to assist those who are not used to it, or maybe having trouble using it. So there are still people who they need to use that and to help service that, and to do the programming. So these are done by humans. So you need to equip yourself a little bit higher than the normal secretarial work, so that you can keep up with the technology. Okay, so it doesn't mean that losing having AI will cause you to lose everything, right? So what is important for you is you have to have the right mindset that AI will not replace humans. but humans with AI will replace humans without AI. Okay, and how do I get started on AI? How do you get started on AI? Okay, you can go to online courses. You can go to, nowadays there are a lot of free courses that have been shared with people. Okay, you can go to AI Singapore and subscribe to their online courses, right? You can go to other websites. You can go to drspacentre.com, to drspacentre.ompay.com to look out for our new workshops. Okay, one will be on video scripting on the 27th of September, 8 to 10 p.m. I think, and also in the morning there will be writing using AI by Professor Dr. Aspalina Alias. So there are a lot of courses that are available, whether it is free, whether it is paid, it is there for you to grab and to utilize what is there in the market. Okay. To tell you the truth, spending 8 weeks on a Coursera or data science bootcamp that you attend does not make you a data scientist, but at least you are prepared to know what is in the industry and to learn and to combine the AI knowledge to enhance the current work and your work process can make you a better worker, can make you a more indispensable worker, and you can excel in whatever things you do. So you must be willing to upgrade yourself. You must be willing to understand that you need, AI is here. They are not going to leave. Okay, unless one day all the computers break down, so there's left with human brains only. But in the near future, AI is AI and it's here. It's already here. It's going to be here. It's going to be here for a while until the future, which I don't know what it lies. But this is what we are facing. So in summary, we have gone through the AI applications that we use every day. We go over the algorithms and what data is. We go through a little bit of machine learning, how they learn patterns, how they learn patterns of data over a period of time. Deep learning, a more complex and more huge number of data that is being used and being utilized to produce an outcome, which is to solve more complex and more difficult problems. We learn how computer sees by computer vision in zeros and ones and vectors, and we learn how LLM works by the language vectors, tokenization. We can do mathematical vector. We learn a little bit about applications of generative AI and how we can use AI to do good or to do bad, to use it in our daily lives and things like that. We also learn the impact of generative AI and how to use AI responsibly. And finally, the jobs, the AI, and what is it in for us? Yeah. Okay. So finally, I would like you to scan this QR code and fill in the quiz. This one is for you to receive a certificate from the first 100. We received a certificate from AI Singapore, and of course everybody who attends and registered for today will be getting the certificate from Dr. Aspar Center. Okay, and make sure you write your full name properly and the email address are keyed incorrectly. There will be no other interactions between the organizer AI Singapore with the participants, right? And you will be notified via email once your e-cert is ready. Okay, so they will send to you your e-certs whenever it's ready, but you will have to wait for quite some time because they need to do some paperwork, and there are a lot of documentation that needs to be done before we can submit it to the AI Singapore. All right. So with that, I thank you. So I'm just going to leave this QR code for a while so that you can answer it. And I would like to return the microphone back to our moderator, Dr. Aspa, for closing up and wrapping up the event.
Okay, Alhamdulillah, syukur pada Allah Ta'ala due to very informative AI introduction by Dr. Jannah. As we know that Dr. Jannah went to AI Singapore, support her to learn this one, and she need to present to hundreds of people in Malaysia. So we hope that the effort to make all the Malaysian people know about AI is spread by this sharing knowledge. So I'm congratulate to Dr. Jannah, give a clap to give us this such knowledge for free. Supposedly need to pay, but thank you, Dr. Jannah, for the wonderful talk. May Allah bless. I also want to share about our latest course on 27 September for who want to learn about AI with our Professor Madya, Dr. Hafizul Fakhri. Within 2 hours, inshallah, you will know how to do a video viral. And whoever want to learn about AI, a practical guide for dentists, you can also join me to learn AI for writing articles for research. So anything from Dr. Jannah, do you want to add?
I think that is all for today. Just I hope that more people will be more aware about the artificial intelligence, and that we will try and learn as much as possible, because AI is evolving and they are evolving fast. At least we know the basic things so that we can equip ourselves with the future technology, inshallah.
Maybe we invite, because we have one student still left, Zaitul Muhammad Saman. Maybe you can give one talk, one speech, whatever what you feel after attending this class. Zaitul Muhammad Saman. Are you here still?
Yes. Assalamualaikum warahmatullahi taala wabarakatuh to Dr. Jannah and Dr. Aspa. Thank you for inviting me to give speech. Actually, the class today is very enlightening for me for about AI, and I think I learned a lot about AI and understand the basic of AI behind it. And I hope I can apply the knowledge I learned today in my life. Congratulations to Dr. Aspar, Jannah, and team. Thank you very much.
Okay, thank you very much. This is the first time we give a mic to the to the participants, and thank you for coming. Thank you very much. Okay, so without further ado, we close our majlis ilmu with tasbih kifarah dan salawat subhanakallah. Assalamualaikum warahmatullahi wabarakatuh, and thank you very much.